Hey everyone, welcome to the video for discussion 2, problem 2. This problem is asking us to find a regular expression for the language of all strings not containing the substring 0, 0, 0. So the last problem asked us to find the language where strings do have 0, 0, 0. So we're basically finding the complement here. Yeah, it's a little bit tricky because regular expressions don't have like a nice way to do complements, whereas DFAs, which we'll cover in a little bit, do. So we kind of have to think about a bunch of different cases here, but we'll see that it ends up being not too complicated. There's just a couple cases to think about. So the way I like to think about this problem is there's really no restriction on ones at all, right? We can write 1, 1, 1, 1 as many times as we want. It doesn't really matter. The restriction comes when we start adding zeros. So it helps to think about basically all of the possible cases that we could have for zeros. So, like the string 0 is fine. The string 0, 1 is also fine. The string 0, 0 is fine. The string 0, 0, 1 is fine. So basically we're bounded by the number of zeros we can have in a row, right? Because otherwise, if we added another 0 to this one, then we'd end up having the substring 0, 0, 0. So we can kind of think about this as like, okay, we can build our strings out of these units that don't violate this rule. Because whenever we hit a 1, we come back to the starting point and we can add up to 2 zeros again. So we can think about these as building blocks. There's one building block here, which is 0, 0, 1. There's another building block here, which is 0, 1. And then there's another building block here, which is 1. Because 1 has no restrictions on it. 0, 1 has no restrictions on it because once you hit that 1, you could repeat it as many times as you wanted, and it wouldn't violate that 3 zeros in a row. And then the same thing here. Now, how do we handle these cases where, so we have 0 and 0, 0, which are not not blocked by a 1? Well, these cases can only really happen at the end of the string. So we can build up our strings out of these 3 building blocks, and then we can just possibly append these to the ends of our strings. And, those can only come at the end of the strings, because if we wanted to continue the string after these, we would need to add a 1, which is already covered by these building blocks. So these building blocks we can think of as repeatable units, and we can just choose between them. So we have 1 or 0, 1 or 0, 0, 1. And then star, so we can repeat that 0 or more times. Basically, you can just choose one of these and we can repeat these and we'll never ever break the rules. And then, like we said, we can append these 2 possible cases to the end. So we have 0, 0, and 0. But there's actually one secret third case, and that is the empty string. Because, for example, we have 0, 0, 1 is a possible string in the language, and this is covered here by just choosing 0, 0, 1 one time, but it's not covered if we just include 0, 0, and 0, because we'd have to add one of those. So we have to include the empty string here to cover all cases. So this is the regular expression for this language. Thanks.